1, 2. Yep, there we go. That's better. Let me chuck that on. And we should be ready to go. Come over here. Go to the slideshow. Yep, I can hear myself on the live stream. It's a bit recursive for the people back at home. In a few seconds when they see me check on myself on the live stream. All right, welcome back to COMP1531. Yeah. I can tell that everyone here and everyone watching live online right now are the real COMP1531 enjoyers, because, boy howdy, lecture attendance sure has. Something happened. I don't know what it was. Maybe it was me. Who knows? Today we are talking about package management, because yesterday, oh, my clicker isn't working. Now it is. Before we start talking about package management, just some reminders. Iteration 0 is due very soon. Can anyone tell me when it's due? Friday? Yeah.
This Sunday?
This Sunday? I believe it is due Friday, which is tomorrow, which is very soon. So I would recommend, is anyone here really surprised by this fact? It is due on Friday though, right? That's consistent with what you're aware of? Cool. Okay, as long as the surprise is due to not me getting the date wrong. Also, we have the labs and the theory quizzes. They are due the Monday after they get released. So I talked to some people yesterday. Who here knows what I'm talking about when I say the theory quizzes? Yep, a few people know what I'm talking about. Just to make sure that everyone is up to date. Those theory quizzes, there'll be 6 of them worth 0.5% of your grade each, so worth 3% in total, which is not a lot, but the goal is not to be an assessment. The goal is not to tell you every single thing about the theory. The goal is to get you thinking critically about the course. And the first one is meant to be a bit of just a freebie. You can try it as many times as you want, and it's just all about how you're meant to behave in the course and the things you're meant to do and the order of operations you're meant to take when things go wrong. So please make sure you do that though, because it is basically a free 0.5%, and over the course of the course, they will add up to 3%, which could be the difference between something, I'm from a university that doesn't use the WAM system, difference between like a high distinction and whatever not a high distinction is. I can't remember. Distinction, I assume. Right, so yesterday we learned all about, oh not yesterday, on Tuesday we learned all about importing our own files and our own functions that we made. We can define a function in our file, we can export it, and we can use it somewhere else. This is incredibly useful in JavaScript and in software development in general, because if you are writing code in a team and you're all working in separate files, at some point you're going to want those files to come back together and work together with one another. We can also import built-in libraries, so things that come pre-packaged with JavaScript, but may not necessarily be necessary in every program, so things like the path library. There was a whole lot of built-in libraries. There was a link in the last set of slides. You can look at all of the possible built-in libraries and see that JavaScript can do a fair few things. Let me just be less annoying. There we go. But what about things that other people have written? Because as I've said many times, writing code is hard and it can be challenging, and it's quite handy if someone else wrote the code for you and then you can just use their code in your own program and not have to write it yourself. Who thinks this sounds great and hopes their entire project can be taken from someone else online? Well, that's called academic misconduct, so please don't do that one. But a lot of the functionality of your program, such as things like password validators and checking if a date is valid, those are things that you should only be, you probably shouldn't be writing them yourselves. They're things that have been written time and time again, and there are standards for them that we have access to. So yes, we don't want to write every function ourselves, but we also need to remember that we're working in a team. And so every package that you decide to install the rest of your team has to be able to install that as well. And how are we going to make sure that everyone can have the exact same thing downloaded on their system? Not only that, everyone has the exact same version of the software downloaded on their system. Everyone has the exact same software dependent on each piece of software downloaded on their system. And if that goes wrong, you run into things like the pad left incident back in 2016. Just to date myself, is anyone aware of the company Kik, the instant messaging company? A few people? Yeah, I feel old. Kik, this guy had this function called pad left, and what it did is that it took a string and it just put some characters on the left of the string if you asked it to. And it was very simple, but a lot of dependencies existed with that package. So lots of different things all around the web depended on pad left existing. This guy also had a package called Kik. The company Kik said, hey, can you change the name of that because you're infringing on our copyright? This man, being the kind of person who puts thousands of things on NPM, said, no, I'm not doing that. Took down all of his packages and broke most of the internet for about 36 hours in 2016. Just the internet didn't work. So we need to make sure that we don't run into situations like that where our dependencies just completely break. So there are problems with packages such as that. And the way that we handle packages is this thing called NPM, which stands for Node Package Manager. We're using Node. We're going to manage our packages. Makes sense that we're using Node Package Manager. We're also going to learn how we can use this to manage our packages, and also the powerful effects that it has, the custom scripts we can use to make our life a little bit easier. And this will play in nicely to the second half of today's lecture, where we get into software testing, assuming we have time. Right, so we want to use a library. For example, there's a library up there called date-fns, which is used to validate dates. But if I try to run it, I get an error. So let's try that now. Let's make a file. In fact, I might make a folder called lecture npm. And I'll put these all on GitHub later. I'll make a file called validationdates.js. And I'll go import is valid from, I believe it was dates-fn, which I believe is short for dates function, date-fns for date functions. And then I'm going to go function checks date, which will take a day, a month, and a year. And it will return is valid new date. And I believe it goes day, month, year, but it might go month, day, year. Year, month, day, of course. Year, month, and day. And what we want this to do is confirm whether or not our day is valid. So let's console.log checks, should be checks date, not checks data. What's a date that exists? Someone tell me a date. And any of them. There's so many of them. 366 to choose from, please. Yep. 5th of October, 2025.
So is date a built-in function in JavaScript?
Date is a built-in object, not a function. So when you call the new command, it makes a new instance of an object because JavaScript decided that just calling it wasn't enough. You had to state that you're making something new because JavaScript is a language that I really like. Let's cd into lecture npm and let's try node. And yep, error because date-fns doesn't exist. We don't have it. So I know someone else wrote this code. I know it exists. I've used it before. But we don't have it. It's not on our system, which is where NPM comes in, which is the Node Package Manager. Manages things like dependencies, modules, libraries. It ensures that everything you have is up to date with what you need to use the libraries that you want to install, such as the date-fns library. The command on the terminal is just npm, so you can run it whenever you want. And we use it to download these libraries which are found on the npm.js website, which you'll become very familiar with. So let's have a look for date-fn and see if it's there. Yeah, it's one of the very first ones that comes up. It is the first one that comes up. It's been downloaded 26 million times in the past week. And this is what I mean when I say that we don't need to be reinventing the wheel. Someone else has already invented how to validate dates in JavaScript. People every week are downloading this 26 million times. We're about to make that 26,589,941 times. But these things are standards that already exist. We don't need to worry about reinventing the wheel, even though that's a big thing we like to do in computer science. We like to program things, we like to make new things. Sometimes things exist, and it's okay to use things that already exist, especially when it comes to things like dates, especially when it comes to things like time zones. If you ever try to program a time zone yourself, good luck. So if we run npm init, it will ask us some questions, and it will let us set up our npm environment. That's my terminal. I'll just clear this. And it is going to ask me some questions. It's going to tell me quite a few things. It'll walk me through creating a packages.json file, which we'll learn more about shortly. First thing I need to do is name it. What's a good name for this package? I'm going to call it date checker, I suppose. Cool. Do we think that this is version 1? Seems like a reasonable version number to me. It's not version 2. Description. Checks if the date is valid by using someone else's library. Entry path, that's fine. Test command. We'll learn more about the test command later. Right now, don't worry about it. Git repository. Don't have one right now. Keywords. I don't really want to add any keywords. Author, Dr. Henry Hickman, very important. It's not that important. License, sure. And then it just asks, is this okay? And I'll say, yep, it is. And now we have this package.json file which describes our project for anyone who wants to use it in the future. So now, if I were to push this to Git, people would have this package.json file, which would tell them what they need to work on my project and what they need to install. However, there's nothing here yet. We've still not installed anything. So what do we think is going to happen when I run? Actually, there's one other thing we need to talk about first. We also add this thing that says type::module. Does anyone know what this means? It's okay if you don't. Yeah?
CommonJS versus ESM, right?
You know exactly what it means. It's because we are using ESM. Does anyone here know what ESM stands for? That's okay, yeah. It is ECMAScript modules. And if anyone wonders what ECMA stands for, I don't know. I never got that far in the acronym. It's too recursive. I'm pretty sure ECMA is going to stand for something with an acronym in it if I keep going down. But the main thing is we're not using commonJS, and we're specifying in our package.json that we are not using commonJS. So that's why we use type::module. So let's add that to our package now. Put it here. I'll go type. Module. Now, what is this thing in package.json? Does anyone know what this is called? What type is this? With its key value pairs? Could it potentially be something we're very familiar with? Yeah. It's an object. It's an object. Everything's an object. It's all an object all the way down. Okay, so I've made this package.json. npm is set up. I'm ready to install my dependencies. So what arduous process do I have to go to? Yep.
What is ESM versus CommonJS?
CommonJS is an older version of JavaScript that people still hold on to very dearly. ESM is the more modern version that we use in this course. I will say the difference between the two is just that we use ESM. You don't need to worry about the finer details beyond that. Just know that we're using ESM, and there are some modules that don't work in ESM. There are some modules that don't work in Common. And you may end up fighting dependencies a lot later where it says, oh, I only support commonJS. And you say, OK, I'm going to find another library then. Or maybe your tutors will have a clever way to get around that. So if I want to install a dependency, the extremely difficult process that I need to go through to install my dependency is I run npm install and then the name of the dependency. Although do be careful with this. There have been a shocking number of times in my life where I've installed what I thought was a perfectly reasonable dependency. I've gone, OK, I want to validate some dates. I'll just run npm install dates. This is an example exaggerated for comedic effect. But sometimes the names are not actually what you'd expect. I go npm install dates. It tells me all about fruits instead. Make sure that the library you're installing is actually the one that you think it is, which is why we have that npm website. It will tell me exactly what to install, hopefully. Yeah, the command is here. npm install date-fns. The ---- save we don't need to worry about right now. So now I'm going to run this. And it's downloading, and it is installed. The package, one package is looking for funding. Who thinks I should give them some? Yeah, no, me neither. Yep, question?
So if npm if the package.json file is kind of the list of all the dependencies,
yep.
Does that mean every time somebody clones the repo, they have to install the dependencies?
Yep, so we'll get to that shortly. But what package.json just did, now that I've installed it, is it says that there's a new dependency. This wasn't here before. But this object was updated with a list of dependencies, and a new file was installed, created as well, called package.lot.json, which says, OK, here's the packages, and here are the packages that it depends on. And here is a package that my program now depends on. The thing about package lock and package.json, oh, actually, one more thing that exists now, is this big node modules folder. This is a folder with all of my basically what I downloaded from the internet in it. And you can see it's now added 5,000 new files to my Git repo. So who thinks I'm going to be pushing all 5,000 files to my Git repo? Who thinks that there's some sort of clever way to get around that will still allow people to install all of the dependencies that I want them to install? Yep, it's the second one. But we'll get to that shortly. So if I come back to my function, validate dates. Let's see if it works this time. Yeah, and it's true. So now it tells me that the 5th of October 2025 is a real date. Hello.
One small question.
Yep.
So what's the difference between package lock and packages? Because they're all tracking the dependencies you've installed.
Yeah, they're
What's
both. So the difference between the two, thankfully I have a slide that tells me this because I forget sometimes. Oh, it's right here.
Oh, right.
Sweet. I'll get to it shortly then. Let's not play around, actually. Let's talk about what the difference is. Package.json is where we store metadata about our projects, which has just a list of the dependencies we need to install, while package lock is storing the information about packages to ensure that everyone has the right one. OK, so one is a list of dependencies, and one is the information about that particular package. They sound very similar, but they are distinct. And this is also a bit of an oversimplification. And it's an oversimplification that you don't need to worry about. Because if we read what packagelock.json actually is, automatically generated, hidden lock files. There's a whole lot of information about what packagelock.json actually is. The main thing you need to know is that it keeps track of the dependencies we install and tells us what they themselves depend on. There's a whole lot about packagelock.json that we don't need to know. And there's also node modules, which is the folder where those dependencies are installed. Now, package.json, it's very important. We should always commit this to Git, because it's important for people to know what they need to depend on to use our package. Package lock should also always be committed to Git for the same reason. But node modules should never be committed to Git, because that's where everything is physically downloaded. And there are some big packages out there. There are some that are gigabytes in size, and pushing all of those to Git is probably a bad idea. But if we're never committing something to Git, how are we going to do that? Have people heard of the git ignore file before? This is the file that allows you to not add things to Git. Tells us not to track certain files or directories. So let's make a git ignore file for the subfolder. So I'll go new file, and I'll go .git ignore, and I'll just say /node modules. And I'll save that. And now you see this has been grayed out, so it's no longer being tracked by Git. So all 5,000 of those files that I was tracking before, I'm just back to tracking 5 now. And so if I want to push this to Git now, you know, sometimes I forget things. How do I push things to my Git repo again? I can't remember. Help me out, guys. What's the first step? What do I do? Yeah. I got to git add. Should I list everything individually, or is there a shortcut I can use? Just do star or maybe period. So it's telling me that some things are being ignored, but I'm happy that those are being ignored, so we're fine with it. I need to make a commit message. What would be a good commit message for this? Something about validating dates. Yeah? Package, stolen, no, yep. All right, I've committed it. We're all done now. Git push, of course. I wish Git were easier, and now it's been pushed. And so now, I don't have the repository open, but we have now got all of those, all of that will be in the repo. And this is the lecture repo, so you can play around with this code whenever you want, essentially. So it tells Git not to track certain files or directories, and it's very good if you have information that you don't want to be public. Can anyone think of information they wouldn't want to be given to the general public? API keys, yep. If you want to find free OpenAI API keys, just go on GitHub and search for them. And you don't need to pay for your OpenAI subscription anymore. You can just steal someone else's API keys. Anything else that we don't want to push to the public in particular? Like maybe if we're using a login system and we have a database of information of some kind. Passwords. Please do not push passwords. First of all, please don't store passwords in plain text. There is a library that will help you not store passwords in plain text, but please don't. All right, let's play around with installing some more packages. Can anyone else think of something we might want to do that we don't actually want to do ourselves? Someone else may have written it. What do people like to do? Use TypeScript instead. There might be a package for that, but we'll cover TypeScript actually in a couple of lectures from now, so we're getting there. Anything? I'm gonna look at the weather. Anyone here like the weather? Any big weather fans? No? All right, yeah? Medium weather fans? Easy way to fetch the weather. Actually, let's search it regularly and scroll through some of them real quick to just look at some things you should probably keep an eye out for. So should I download this weather, which has 308 downloads? Or would it maybe be a better idea to download this weather icons, which has 30,000 downloads? You should probably keep track of the how many downloads they have in the past week as an idea of how reliable they are, how useful they are. Another thing to keep track of is when they were last taken care of. So this one was 10 years ago. So it's probably not very up to date. This one was 6 years ago. This one was 6 months ago, so this one might be good. What about something to do with passwords? So right, I've got two options. I've got password for a password generator, which has 1,400 downloads, or I have a password prompt with 35 million downloads. Granted, these are two different things, but if they did the same thing, you had to choose one, I'd recommend choosing the one with 35 million downloads instead of the one with 1,400 downloads. Password sheriff, which will keep track. Dead simple password validation. Well, this guy's got a troll face sort of icon, so I'm going to choose his. That's another good way to pick your passwords. Actually, no, I'll choose this password validator here. I'm going to run npm install password validator, I don't know what this library does. I mean, I hope it validates passwords. And once I run it, if we go to package.json, you can see now it's telling me that there is another package I've installed called password validator, right? And we're running on version 5.3, and this is something that people need to know if they're going to use our package. If we come over here, there's more information about password validator. It tells me what version is here, its integrity. I don't know what the integrity hash means, but that's some sort of hash that verifies it. What version of node is required, the license that it has. And so this is metadata about the packages that we have installed versus just a list of those packages. All right, I've downloaded password validator, so now I'm going to play around with it. What can we do? Ooh, now, this terrifies me. Why should this terrify me? Why should this terrify all of us? This is commonJS. This is how you import things in commonJS. Do we use commonJS in this course? No, but I'm going to see if I can make it work anyway. Also, if you see var, we use let instead. I actually quite like the word var because it's short for variable, but I'm not going to go against, you know, the greater will, as it were.
But it's the same thing.
They are the same thing. But we don't use var. So let's import password validator from, what was my package called? Password -validator. Cool. I'll make a function. I'll call it check password, and it will take a password. This package is a bit interesting because you have to define a schema, so I'll go let schema equal. You see there's that new keyword again. That new keyword means we're creating a what? An object. There's that enthusiasm for a Thursday at 2 p.m. that I'm looking for. And then I'll just quickly go schema.is.min8, which says checks if it is minimum of 8 characters long. Cool. So now I'll console.log schema.validate, I believe, and then whatever password I've passed in. Yep, console.log schema.validate, and then whatever password we choose to pass in. Quick, someone shout out their password to me. I almost got you. Next time. And what bank are you with again? I hear NZ, I'm happy with that. Right, so I've done everything. Who thinks this is going to work perfectly well? Some people have faith in me. I appreciate it. Nope, it's broken. The reason that it is broken is that it is a commonJS module, and it will not play nicely with what we want to do. So if the module only supports commonJS, you need to do a lot of fighting to get it to work, and sometimes, hello?
Just wondering, when you install that package, is it only within that folder?
It is only within that folder, that is correct.
If you want to use it in a different project, you have to reinstall it?
Yes, but we will get to that very soon. That is a great question. So yes, when I install it, it is only good in this folder. If I want to use it in a different project, I need to install it again. Well, it sounds really annoying. How am I going to keep track of all of the things I need to install? But luckily, there is some sort of package manager that we can use that will help us keep track of everything. Hello, up the back.
Is everything already installed in SSH, or we need to do it separately?
This should already be installed. The NPM is installed if you have JavaScript installed. And if you have NPM installed, then you're good to go. But your individual iteration or your individual projects will use the packages that you think are worth using. It's not up to me to tell you that you should use date-fns. Maybe you find a different package you'd rather use instead. And so your individual package choice will be up to you.
But the teams should have the same package.
The teams will need to have the same package, like within your team. But we'll show you how to make sure that that works very shortly. I saw a hand.
Do we have to just say why we used it or we used it?
You can write about it if you want, but it's probably fine to just use it. If it makes sense to use. we should be fine with it. All right, I'm just going to quickly, even though it doesn't work, I'm just going to push all of this. Git commit -m. It's just going to say broken, sad face. This is a bad commit message. Don't push things that are broken, but I'm doing it for instructional reasons, so I'm allowed to. So by committing our package files, we have ensured that our environment can be replicated by anyone as long as they're willing to read through our package files and figure out what on earth we've done and figure out how it works. And if I clone my repo, the node modules folder will not exist because we've not pushed it, so it can't exist. But there is a way for us to fix that. So let's clone my repo fresh. Where's my code? What did I last push? 40 seconds ago? That sounds like what I did. And it even says broken sad face. That seems good. So I'm going to go code, clone with SSH, cd dot dot, cd dot dot. I'm going to make a directory called example. Okay, example already exists. I'll make a directory called example2. I'll git clone. Okay. Okay, that's not working how I'd hoped. What if I back out even further and just git clone it here? Okay, it let me do that. This is what I just cloned. I'm opening that workspace now. As you can see, my node modules folders in both of these examples no longer exist. They're not there anymore. And so now I need to go through package lot. Okay, this one depended on these two, and that depended on, it wants funding, and this one also wants funding, and okay, this was made by Dr. Hickman, and he has these two dependent, oh man. There's a lot to go through, and imagine if you had hundreds of packages installed, how many you have to go through and individually install each one of them. That's a real nightmare. Let's not do that. Let's do it in a slightly different way, in a slightly nicer way. So how do we fix this? We can just run npm install in the top level folder, and it will go through package lock, and it will go through packages.json, and it will install all of them for us. Which means we will install the correct dependencies. Let's try that out. Let's not use Copilot. So I'm going to cd into lecture npm. I'm going to run npm install. And all of those packages that I needed have now been installed. So if you commit your package lock and you run npm install, it will update and it will install the packages that you need to use that project. And so we no longer need to share the gigabytes and gigabytes of files with our teammates. We just need to share package log and package.json, and with the power of npm install, we can support each other and we can have any package that we need. One thing npm lets us do, sorry, was that a hand? No, okay. One thing that npm lets us do is add custom scripts to our package.json file. We'll get more into that in the second hour. But a very cool thing we can do is using a mixture of Bash and JavaScript, we can run commands from npm and we can add our own custom commands to things. They are a mixture of Bash and JSON, and let's see what one looks like. So in package.json, we've got scripts like this one, test, but I'm going to make a new script called Henry, and it's going to say, please don't spoil Survivor 49 for me. I can't watch until the lecture is over. So I'll save that script. And now if I run npm, I believe it's npm run Henry, it echoes it out. Oh, Whoops, I need to echo it. Echo / quote. And then echo is a bash command that says put things in the terminal for us. And now in the terminal, with my command, I've done npm run Henry, and it says in the terminal, please don't spoil Survivor 49 for me. I can't watch it till after this lecture. Just for no particular reason. This becomes very useful when you want to do things like making your testing slightly easier, which is what we're about to do in the next hour of the course. But these let us define our own commands and run them in the terminal using a combination of bash. We will tell you what to do for now. In the future, you'll be writing your own custom scripts and commands to do things, so you may be learning a bit of bash or a bit of JSON. That is all about node package management in about 35 minutes. Does anyone have any questions about this particular topic? Is everyone relatively happy with NPM? Okay, I'm going to do an early break because the second half of this lecture is another continuous topic and I don't want to interrupt in the middle of that one. Before I give us that short break, I'll see if there are any questions online. But remember how on Tuesday I talked about the 4 equal signs and everyone was like, no, that can't be a thing that exists. It's not a thing that exists, but there is a reason that I wish it was. Where do I keep my things? I wish I had a structured file hierarchy. Yeah, that'll do. A very quick bit of JavaScript nonsense. These 2 objects, are they the same thing?
Yes.
Are these 2 objects the same? Hands up for yes, they are the same. Like visually, are they the same? Do you think?
Tell me you're comparing the address of them.
If I compare these, okay, these 2 objects are the same, but if I compare them, who thinks it's going to evaluate it true? And who thinks JavaScript is going to mess with us? Because otherwise, why would I be doing the demonstration? So if I run node deepcompare.js, these 2 objects are not considered the same. But thankfully, we've got the triple equal sign to come in and save the day. So who thinks that now they're going to be true? No, they're still false. There is no way to deeply compare things in JavaScript. To do this, you'd need to loop through each object and individually compare each element to it. There are a few workarounds, such as my favorite workaround that is genuinely used is that they turn the objects into strings. So if you turn your object into a string and then compare it, then you can check if they're equal, and then you can turn them back into objects. Hello.
Oh, what if you spread it and then compare it?
What if I what, sorry?
Like use the spread, like the dot. Can you
I've
do that?
no idea what the spread is. I've not heard of that before, but there probably is. You can turn it into lists of key value pairs, do you mean, or?
It's like, I think it turns it into like individual, like let's say you have an array of 1, 2, 3, 4, 5.
Yep.
Turn it into like string literals of like 1, 2, 3, 4.
Yep. Yeah. So that's essentially what they do to compare them. Yep. Yeah. We use JSON.stringify to turn them into strings, compare them, and then turn them back into objects. It is really silly, but it's actually a problem in a lot of programming languages. You might not be surprised to hear. Even though I love picking on JavaScript, this is actually just a general how do you deep compare things problem. All right. I can feel the energy in this room is really rising, and I know that we kind of just want to smash into software testing right now with no break, but I need water, so I'm going to give everyone a 10-minute break, stretch your legs, go to the bathroom, get a drink, come talk to me about package management, and then in 10 minutes we will talk about software, about verification and testing. I'll see you all in about 10 minutes.
I have a meeting. I'm not Henry.
Bye, Dragon. 1, 2, 1, 2. We're so back.
Let's say you merge and so like conflict to resolve, they won't actually that person change won't actually merge into
Right. We're coming back. What I'll do first.
No one's looking at Teams. You can just like send a message there and send a message on Teams and tell the guy on Instagram to reply on Teams. It's like so sad. Trying to get someone to reply on Teams.
Yeah, like announcements and stuff.
Wait to elect to demo. New file. Function.js. And I'll see if I need that.
Staring at my emails in Microsoft Teams 8 days. Check like 20 times a day max.
Also,
All right, here we go. Hey everyone. Yep, microphone's working. We're now going to talk about dynamic verification, which is a form of software testing. So we're going to be verifying that our software actually works, which is a far cry from COMP1531, where we looked at our code and went, it's probably fine. So, oh man, I forgot to add all of my animations. That's so sad. Okay. We need to ensure that an application actually works, and to do so, we need to write the tests for doing this. And if we do tests the right way, we will actually get results out of it that tell us our program is working. And we need to understand the characteristics of the language we're working, otherwise bugs are inevitable. However, we're using JavaScript, so bugs might end up being inevitable, because who understands the characteristics of JavaScript so far? I don't. So we're going to learn about abstraction and black boxes, designing by contract, Jest, and what is safety in our program, how to make our program safe and secure, and what the difference is between a safe program and a secure program. So the reason we need to test our software is because if we don't, there are ramifications both financially and like in the real world. Not only, so when Nissan had to recall 1 million cars because of a software bug, they lost millions and millions of dollars, and there were risks that people's lives were in danger because of those cars not having their software properly tested. There was a $1.2 billion military satellite failure, which could have been entirely prevented if the software was tested just slightly more robustly. Who here remembers the CloudStrike outage of a couple years ago? Yep, basically all of the internet went down because of a regular expression. To be fair, if you've come across regular expressions before, fair enough. It's fair that that took down the internet. Regular expressions are meant to be understood by no one. I don't like them. But still, if they'd tested that it worked in a few more cases, we might not have had that problem. And the US economy on its own was cost $1.1 trillion in 2016 just from software errors occurring. And 4.4 billion customers around the world were impacted by software going wrong. Now, I don't think our software is going to be used by 4.4 billion customers, but it could be. And you probably want to make sure that it works, just in case. When we test our software, what we're showing is that our systems work exactly as we expect them to work. Sort of. Can anyone think of a counter to what I'm saying right now? That software testing shows the systems operate as expected. Any reasons this might not be the case? Well, let's think about scale. How many cases can you think of for your software? How many different scenarios are there in which your software can be used? Well, let's scale it back a bit. Let's say I want to ask what your birthday is, what are some inputs that I might get from the user? Yeah. I might get a date object. What else might I get? How can I format a date? What are some different date options if I said, just give me your birthday? Yep.
Day, month, year.
Day, month, year. Year, month, day.
Year, month, yeah.
Month, year, day.
Day.
Month, day, year. Oh, who here says their birthday is like October 1st versus 1st of October? Who here says they're born on October 1st? I mean, not, your actual birthday, though. Like, who puts the month first when they say it? And who puts the day first when they say it? And who here hasn't thought about it before? Yeah. Or maybe someone will just say, I was born 30 million seconds after 1970. Because that's actually how we keep track of dates in tech. We count the seconds from, I believe, January 1st, 1970. And that's just how old someone is how many seconds it was since then. So there are so many different ways we can get input, so many different ways our software can behave, and we can't think of all of them. There are lots that I haven't thought of yet. So software proves that our systems are operating based on what we think is going to happen, which may not actually align with what happens in the real world. Now we want to verify that the software is doing what we expect within that bound. We want to make sure bugs don't occur. We want to make sure that our development costs are low. And we'd like to make sure that we are improving the performance of our software. We don't want to be regressing. That's the last thing we want our software to do, is go backwards. And you've all been has anyone here been developing their code, developing their software in iteration 0? Anyone been working on iteration 0? Hopefully everyone. It's too soon, guys. Hopefully you've all been working on it. Who here has been testing at the same time? Anyone? Yeah? Has anyone just made the implementation and then not tested it yet? Has anyone not tested yet?
No, iteration 0, you just write the function stop. You don't need to test it.
Great point. Very good point. I forgot. Okay.
You have a dry test runs,
Yeah. I forgot that iteration 0 doesn't have testing. That soliloquy would have been so great if I reviewed the course content beforehand. But in general, when you develop, testing happens in parallel with your development. And there are lots of different types of testing. So we've got acceptance testing, and acceptance testing is more a business kind of testing. That's testing whether the software is appropriate for the business to use. So someone who is in charge of the business or works for the business might come in, look at the software, play around with it, and go, yep, this is acceptable. There's integration testing. So when you have your different functions, they're going to work together. So integration testing is about testing how different functions come together and behave. There's unit testing, which is where we zoom really far in. We test individual components. We test each individual function and the cases we expect it to handle. There's usability testing, which is actually not about testing the functionality, but more about testing how it is to use. What's it like to, if I click on the button, does it make me feel good? Is it a zazzy enough button for me? There's functional testing, which is just concerned about the output. We don't really care about what's going on inside of the program, which is the case for most kinds of testing. When you think about what you're testing, normally what you care about is what it outputs. You don't really care that much about how it gets there or how it comes to the answer, just whether the answer is correct or not. Who here, back in, I'm going to say year 6 or 7, they did those maths tests and the teacher was like, you've got the answer right, but your working was wrong. Has anyone here experienced that before and got really upset about it? Yep, a few people. Well, normally we don't care that much about it here. We care more about, do you get the right output from your program? How do you get there? Not too concerned. Except when it comes to performance testing. Because if your program takes thousands of hours to calculate 2 plus 2, I'm going to be concerned, and we're going to start asking questions about that one. So there are lots of different types of testing. Yep.
So like performance time complexity, right?
Yeah, performance is time complexity, performance is big O notation. Don't get me started though, because asymptotic time complexity is one of my favorite topics. I see a question on the live. Sometimes we don't know how they'll operate. I don't understand that question, sorry. Please repeat it in a way that I understand. Yeah, big O notation, things like, sorry, don't even get me started. Data structures and algorithms, one of my favorite topics, including asymptotic time complexity, but yes, it's the speed of your programs. And they've not repeated it yet. There are 2 types of software testing. The one we're focusing on in this hour is exercising and observing the behavior of the function or behavior of the product. This is known as dynamic verification. The reason it's called dynamic verification is because we actually run the program. We actually check whether it works or not. We check whether it has been, when we execute it, what happens. There is also static verification, which we'll get to we'll get to next week. Static verification is all about testing before we run the code. That's things like checking that all of our comments are well formatted, checking that we don't have break statements in our while loop if you believe that those are bad, checking we have if statements with the else statements that come with them, sort of the rules that come with linting and static verification. Sometimes it's called a compile time check when we do static verification, and JavaScript is not a compiled language. Well, it compiles and runs at the same step, but just know that compile time check just means doing it before we actually run the program. Today we care about dynamic verification, and next time we'll worry more about the static stuff. Now, software safety and software security. The goal of testing is to make sure that our software is safe. I planned to ask you what you thought the difference between safety and security was, but my animations broke, so you can just see what the difference is. But when software is safe, we're protecting against accidental misuse. And this is important to know because if I were in the position to write theory questions for a quiz of some kind or an exam of some kind, this is something that I'd probably put in it, just a heads up. So safety is stopping things from being accidentally misused. Hi.
So for like theory questions in exam and the quiz, are they like based on like kind of like the SLDC stuff?
They're based on topics covered in the lecture. It can be SODC stuff, but it will never be something you've not heard of before. It hopefully will not be something you have to go out and Google. It should be accessible from what's in the lectures, doing the labs, reading the lecture notes. And especially in the final exam, they won't be something that you've never encountered before. It will be reasonable for you to have encountered it before.
So it's all in the slides?
Well, the slides are a complement to the lecture. So I might say something in the lecture that's not explicitly said in the slides, but is covered in theory. But anyway, safety is preventing from accidental misuse. So think of guardrails on stairs. They stop me from falling down the stairs by accident. Security in software is preventing it from deliberate misuse, so malicious actors and people behaving in unsafe ways purposefully. And there is a key distinction, and you should keep that in mind, because the goal of testing is to improve our software's safety. Improving our software's security is a whole other step that doesn't really come from testing. Well, it comes from a different kind of testing that I don't believe we get too much into black pen testing during this course. The thing about software is that it becomes unsafe when unexpected or unintended behaviors are allowed to happen. But thankfully, we're using a very sensible programming language that would never let us do anything weird or behave in unexpected ways or behave unintentionally. We're using a very nice and sensible JavaScript, which, as we all know, behaves exactly how we want it to at all times and doesn't do anything weird at all. So really, the importance of software testing just got a lot more important because we're working with this guy. To be fair, the two types of software safety that I'm talking about here, when I talk about reading uninitialized memory and writing outside of array bounds, those actually can't be done in JavaScript, but they can be done in C. And you've all got experience stopping it from happening in C, so you'll have to deal with different kinds of weird things happening. As a fun aside, 94% of spreadsheets have an error in them somewhere because there are so many cells in a spreadsheet and people don't test them, even though a spreadsheet is as powerful of a programming language as JavaScript because both of them are Turing complete and both of them can be used to program theoretically anything. People don't test their spreadsheets, and these can genuinely end up costing companies millions of dollars because someone forgot a comma somewhere and there's no cross-validation of whether or not your spreadsheet is behaving how you would expect it to. And we're dealing with programs that can be used by far more people. As I talked about just earlier, C is not memory safe. You have to malloc and realloc and free and all that fun stuff. Who remembers the memory allocation from COMP1511 and 252? Who was taught it by me? Oh, I knew some of you were. Maybe you didn't show up to this lecture. JavaScript, though, is memory safe, and so we don't actually need to worry about doing things like allocating arrays out of bounds. Let's even try doing it and see what happens. I'll make a new file called outofbounds.js. Function. I don't need to make it a function. Let my array equal 1, 2, no, I'll do different numbers. 12, 54, 34. That's a dot. That should be a comma. And if I go my array 3 equals 19, and I console.log my array, what would happen in C here? What do we think would happen in C?
Memory over or something?
There'd be some sort of memory issue because we'd be in C. You can access the memory. You can access and overwrite your computer's RAM, which you shouldn't try and do. Now let's try node. Okay, it just lets me do it. It just says, okay, you can have something. We'll put it there. There you go. What if I do 5? What do we think is going to happen now? It says, yep, you can have it there. I'll give you 2 empty slots. It's not even filling them with anything.
So what's there? Is it null?
I have no idea. Let's find out. Let's console.log my array 4.
It says empty.
It's undefined, which is different from null.
What is that?
It's another fancy word for null, but it's different enough to cause real problems with us. It means that it says, but I know you need this memory for something. You don't care what's in it. I don't care what's in it. Undefined, which is separate from null, which is I know you want this to be empty because it doesn't know if we want it to be empty or not. So it just says something might be here. So memory, we're safe on memory, but we're not safe on having programs expect how we would expect them to behave. Sorry, having programs behave how we'd expect them to behave. We do dynamic verification during the execution of software, and it's usually what we mean when we say that we're testing something. If we're testing something, we're normally running the code to see if it works or not. And we can test in the small, which is things like unit tests that link in on individual functions and how they work. And there's testing in the large, which is more about how the program all links together. So things like if you click a button, does it do what you expect? Because you may not have gotten into this quite yet, but when you click a button, a lot of things happen. You click a button, the button's listening for an event handler for when you click that button. That event handler then calls a function, which then might call another function, which will then return something, which will then return something, which will then display something on your screen. Testing in the large is very important to ensure all of the pieces work together. It doesn't matter if all of the individual pieces work, if they can't actually fit together into a cohesive program. And here's a quote that I'm hoping that you can really get behind, which is testing shows the presence of bugs. Testing does not show the absence of bugs. And that was said by Dijkstra. Dijkstra is a very famous computer scientist. He also said that computer science is no more about computers than astronomy is about telescopes. People say that he said that, but actually a friend of mine said it to him. And that's why I really like computer science, because if I were a philosopher and I said, actually, no, Aristotle didn't say that, it was my friend who said it to him instead, you'd all look at me like I'm an insane person, which, to be fair, you sort of are doing now, but that's unrelated to this. The second quote is not important. I just really like it. The first quote is very important. Testing shows the presence, not the absence of bugs. Testing can only confirm if bugs are there. They can't confirm that bugs aren't there because of all of the different scenarios that could come up with testing. Because it's meant to say in the real world, bad things happen. Because think about the average user. Think about how smart they might be. And half of your users are below that, just by definition of how averages work.
2080 rule.
Yeah,
For a
2080 rule.
smart person.
Yeah,
80%.
yes, 2080 rule. Dynamic testing ensures that it is more robust, especially when things go wrong, and please do not fall into the trap of thinking that your code will never break and it will always go exactly as you expect. Things will go wrong, users will do unexpected things, it's just something we have to live with as software engineers. It also prevents our code from regressing. The thing about testing is that it stops our code from going backwards, because who here has been working on their program late at night and it sort of works, and so they make some changes and then it really doesn't work? Has anyone experienced that? Yep, I've experienced that, and sometimes I don't notice until later that my program went from sort of working to really not working. But some things don't forget, and software doesn't forget, and tests don't let you regress. If your code was passing all the tests and you implement some new features and suddenly previous tests are now failing, that's good to know that you've done something that has broken something, and your tests will not fail you in that way. Right, so unit testing is the process of testing individual components, functions in isolation. And yeah, as I've said, testing in the large exposes defects in bigger integrated systems. And there's lots of different kinds, like module tests for testing entire modules, as the name implies. System tests test the entire system put together. There's lots of ways to be testing in the large. It doesn't just have to be the entire system put together. It can be modules that depend on one another. It can be integration between two different functions. As long as you're testing more than just one individual function, you're probably testing in the large. So let's look at this piece of code, which is designed to add all of the even numbers to a list. How would you test it? I'm going to give you a minute to turn to your neighbor and talk about how you would go about testing this. Like, what would you write? What would you do? So turn to your neighbor, have a quick minute chat. Right, so we'll bring back in here. So first of all, what are some cases that you would test this on? What are some potential inputs that we might want to deal with? Yep, up the back. You?
Limit's negative.
If it's negative, yep, it's not going to work if it's negative. Any other scenarios we need to test? Yep.
The wrong data type, like strings or objects.
Yep. So someone might pass in a string, or they might pass in an object. Is there anything else we need to test? Yeah.
I guess just like a normal case.
Yeah. Sometimes when we're testing, we get really caught up in testing the abnormal cases, things like negative numbers and strings and whatnot. Sometimes you should just test if it like works on the expected scenario. Yeah, again.
If it was negative, it would just like return nothing. So
Yeah, it would return an empty list, which is sort of true for the functionality of the program, but yeah, it doesn't work for 0. Nice, that's a good one that I put in on purpose. It does not count 0 as an even number. Anything else? No, and now the question is, how? How are we going to test this? What mechanism do you have in your arsenal right now to test these sorts of things? In the front?
you can make like txt files and pack them through, and then like check them against like expected outputs.
Yep, so you can compare expected output. That's a bit more complex than what I'm looking for right now, but that is a good answer. Yep. Yeah, the classic. Right now, what we're sort of equipped to do is console.log things and inspect them and see if they work or not. But what are some problems with this console.log method? Like, not, yep, back there.
Only a limited number of cases that can be covered.
Yeah, there's a limited number of cases that can be covered. Yep.
I guess maybe you'd also have to like figure out what it's meant to return.
Yep.
It's like the big cases.
So the big problem here, not only is it limited in how many times we can do it, because we can only write so many cases, but also we need to be thinking when we click run, what do I expect to happen? What output do I expect? And then we need to manually inspect every single one and go, okay, is that what I thought was going to happen? It is. Okay, next one. Is that what I thought was going to happen? Okay, it is. Next one. And if you're working on a big piece of software with hundreds of tests, it's a lot nicer if we can just have something automatically tell us what the issue is and whether or not it's worked. And so what we've demonstrated here, this right here is actually not testing. This is a form of debugging, which are distinct and different things. It's only testing if we can scale it up and we can make it work on larger scales. Debugging is a type of testing, but testing is not just debugging. There's more we can do here. We try and do this thing called black box testing, which is a form of abstraction. The reason that we care about black box testing, the reason we do it black box, is that we actually don't care that much about how it was implemented. We just care if it works here. So if I have my car and I drive it somewhere, I don't really care about how the engine works. I just care that when I get in the car and I turn it on, it starts and I can drive somewhere. When I turn on my computer and it works, I'm just happy that it works. I'm happy that it passes the test. Do I care about why it's passing the test? No, I just care that it does pass the test. This is when we're writing our test cases. This is called black box testing. And we normally try to write our test cases before we implement our function, because it shows that we're really thinking through the possible scenarios. Now, I will admit it's very easy to just claim you've written the test beforehand. We're not going to be that strict about it here, as long as you have good test coverage. An entire point of my thesis was fighting against the idea that we have to make students write their tests beforehand, because we can tell you to, but like, what am I going to do to prove it? Nothing. It's fine. So it is good practice to write your test beforehand. Sometimes life gets in the way, and I can't force you to do it. Yep, there.
Is it better to write the tests in another file, or would you have just put it on the same file?
So we're going to go over a framework that will put the test in a different file, but there's a whole framework to make our testing more scalable and more robust. Yep, sweet. But for these functions, which currently don't do anything, can we write tests for them? Does anyone have any idea, can we write these test cases? Because the functions don't exist. We don't know how they work. We don't know what they do, but can I write test cases for them?
Yes.
Yep, yes, good. Why? Why can I write test cases for them? Yep, the function is specific. Yep, something else?
Because in a certain sense, you usually only have like the interface. They won't have like the full implementation.
Yeah, so when we're given, so we're normally, you're normally given just an interface, did you say?
Yeah.
Yeah, or like when we're working on our, you can see, oh, I'm seeing things in the chat. Oh, yeah. They're not questions for me. And in this course, we normally just tell you what we want implemented and not necessarily how, but we'll tell you, it needs to handle positive numbers and negative numbers, or it needs to handle this type of input and produce this type of output. There's a lot that you can get just from the function stubs and from the documentation to tell you, and from the specification to tell you how to implement these things. So yes, because the implementation itself doesn't actually matter for our testing case, we can write some tests here. Again, these are not quite the sort of tests we'll use. They're better than just regular console logs, because now we've said what we expect things to happen, and so we would expect all of these to output true at some point. So let's go to, in fact, let's write one up. I may have written them all up. You can't, yeah, you should probably use console.assert, which is what I did in the extra quizzes. I just put console.log because it outputs true nicely. And we'll sort of jump over console.assert. We're going to go straight to Jest testing. But if I implement this function, I've gone through a very political stance here, and I hope people aren't too upset with it. I've decided that Y is a vowel. Is anyone here? Yeah? Yeah. One person. Let's go. Did someone just say that doesn't make sense? Y is a vowel. I'm standing by this. So I'm going to replace any A with nothing. I'm going to replace an E with nothing. An I with nothing. An O with nothing. And for the people, a Y with nothing. And I'm also going to return the word.
But this doesn't work.
It might not work. Let's see. So if I clear this and I node blackbox.js, no, it doesn't work. Why does that not work?
If you use a loop or something.
Oh yeah, good point. Well, I forgot that U was a vowel, first of all.
Just replace Y with you.
Word.replace should work. It's a thing that exists in JavaScript. The .replace method is a function. But I don't.
It should work. Yeah.
Let's see if that works.
Yeah, it should work.
Funnily enough, my tests down here are a bit tricky for me to read, so I'm actually going to get rid of the equals equals thing here to see what my program's actually doing. It's just not doing anything. Maybe I need to go word equals. If I go word equals, is that going to work for me? There we go. We need to go word equals in front of all of them. Now there are more efficient ways to do this. Although if I want to be really pedantic about it, this does run in constant time, which is something you'll learn about in 2521. And imagine, what if the number of vowels increased? If it ran in linear time, that would be a disaster. I'm adding Y back. I will not be silenced. It is. My name is Henry. The sound comes from the Y.
Yeah. Makes sense.
Yeah. I've caused a political riot here. So now I expect it to equal 8nr. Yeah, people are saying to use console.assert, which is a good thing to keep in mind. And now I'm passing some test cases. So even though we hadn't done the implementation, we can still write the test cases beforehand. Because the actual implementation doesn't matter for what we expect to happen. In fact, if I'd written my function first and then written my test cases based on what my function was doing, my test cases would all suck because my function didn't work for a while there. So if I wrote my function and said, I think my function's fine, and then said, I'm just going to write test cases that fit to what my function does, we're writing bad tests because sometimes our code doesn't work. Now, in order to test, we're going to be using a package called Jest in order to test at scale. It is installed with npm, and it's installed with savedev, because sometimes things are only needed if you're developing. They're not needed in the production version. So we're using ---- savedev in this install because it is a development feature and not a production one. Now, I've already installed Jest in this folder, so I'm actually going to leave slightly to the demo. It's going to write a function called is odd number, just a classic. Return number mod 2 is equals 1. And now if I come to the terminal, I'm going to go npm install Jest. It will take a bit to install because it's quite a big library. And we're good. Just so you know, installing Jest added 298 packages, and 44 of them want my money. But I have to afford rent in Sydney, so I'm not going to give them that. I didn't do save dev. Oh, man. That's the one thing that I said we were going to do. If you're a better person than me, make sure you do save dev. I don't think I can actually fix it now. Okay, hopefully that's changed it over to save dev. So let's consider our remove vowels example from before. We need to write some tests for it. So what we're going to do first is we're going to export it. I can either export it as default or I can use my named exports. Which one do we prefer to use in this course? Named exports. With all the enthusiasm you can muster, we're going to export is odd. Now I'm going to write a new file called myfunction.test.js. This is a file for writing our test cases. The syntax for writing test cases can be slightly annoying, so I'll walk through it one step at a time. So the first thing we're going to do is we're going to import our function. So let's import is odd from my, what is it? It's /myfunction.js. This is how we import it. Next, what we do is we're writing a test case. So we're going to put test. Test is a function from Jest. We're going to go test. And the first parameter that gets passed in is a description of what we are testing. So what's a scenario that we could test with our isOdd function? What sort of scenario could we be testing? There are sort of only two scenarios. Yeah? Base case? Okay, I like base case, but let's be a bit more descriptive. Like let's talk about what we're testing. Let's say maybe we're going to test, so we can test for odd numbers and we can test even numbers, right? So let's test positive odd numbers first. Let's go for that. Tests positive odd numbers. Now the second thing we do, and I'd like to emphasize that this syntax is annoying and you don't need to know exactly what it means, but the second parameter of test is a function with curly brackets and an equal sign. Regular brackets and equal sign, that's an arrow, and you do that. Now inside the second function, we're going to write what we expect to happen. So I'm going to say expect, expect, I swear I'm not typing that. One more time, expect, open bracket, thank you, is odd 1. So I'm saying that when I call is odd on 1, I am expecting something. I am expecting it dot to equal, and what do I expect is odd 1 to equal? True or false, or we'll go with true. And now we can run our tests. Or can we? You're about to learn that ESM can be a pain even more than we'd expect.
Why it's so long?
Why is it so long?
For testing purposes, it should be very simple.
It should be, and we're going to write a script to make it more simple. The reason it's so long is because it's inside that subdirectory. It's because it needs to go into node modules, it needs to go into find what we're looking for. So we need to go /node modules /bin oh, there's so much. You're right, it's so long. /jest, and we're going to run myfunction.test.js. Make sure that I save it. And we're going to get an error. Definitely is found. Oh no, I'm in the wrong place. No, I'm not in the wrong place.
Node modules?
Oh yeah, node modules with an S on the end. Not node modes. Node modules. There we go. No, what is wrong with me? node modules. Oh, it's .bin, of course. If only there was some way to make this shorter and easier to do. Foreshadowing. Failed. The reason it failed is it's saying that I can't use the import statement. What does this mean? What have we run into now? If it's saying that I can't use import, what's the name of our enemy from earlier? It's commonJS. It wants us to use commonJS, and we're not doing that. I refuse. I refuse to use commonJS, and so we're going to go back to that script we were talking about before, which will also make it easier for us to actually run our tests. Now, UTAO didn't have this problem last year, and I don't know why, so maybe this will work out of the box on SSH. Feel free to try it out. But I spent almost an hour yesterday trying to get Jest working on my computer. I spent a long time Googling, and hopefully now you don't need to worry about it. We need to put a script into our package.json, which means we do not need to run that entire line anymore. What this script does is it adds an experimental VM modules stuff, which means that it Jest claims that ESM is still not stable after however many years it's been, and so it's still in an experimental phase. And so we add a flag that says, run the experiment. When I made these slides, I thought to myself, it'll be good for my students to write this in themselves and not just copy and paste it. And now that I have to write it in myself, I wish I'd just put it in for copy and pasting. Luckily, I do have it hidden somewhere. I'm gonna do that thing that I don't think you should do. Let me just steal that. And you will be able to do this copy and pasting stuff because this Git repo will be available to you anyway. So if you have the same problems that I do, you can take it. Package. I didn't initialize my npm either when I came into here. That's not ideal. Let me just quickly run npm init. Is that not what I want to do? I don't remember the command for initializing npm that I talked about earlier in the lecture.
Initialize? npm init?
It should just be npm init.
It is.
Oh, okay. Didn't work for some. Yeah, it should, oh, it's yeah, it is just npm init. Why did it not run? Maybe it's because I've already done an npm install. That would be funny. I never quit. Oh, I see. Okay, I thought it was telling me to give up.
Never quit.
Yeah, never give up. Always do your best, everyone. No, I was going to abort. I'm going to go to the one that's working already. Make sure you run npm init first. Trial by fire. Right, so we've got remove vowels, which removes vowels from a word. And we have remove vowels.test. There are a lot more tests in here. And if we run, with that command we had from before, if we run npm run test with remove vowels.test.js, it goes through and it tells us what tests it's passed, what tests it's failed, and why it's failed them, which is much easier than dealing with it one at a time. I'll go through all of the syntax shortly, but essentially on the outer level, we describe the bigger picture of what we're testing. So we're checking if multiple different functions work from this module. So that's what my outermost describe does, and it does the same syntax as test. Inside the describe, I do a second describe. So I'm saying I'm testing the remove vowels function. And if we come down here, my first describe says I'm checking multiple functions. My second is the remove vowels function. Then I have a test that says deals with no vowels. So we're checking words that don't have vowels in them. So ABC, that has vowels in it. Egg on my face here. But it only works for lowercase, so let's update that. Deals with uppercase, and I'm going to say that I expect ABC to equal to BC at the end, and I expect BCD to equal BCD. Again, be careful in writing your test cases. Your tests are only as good as you are, and if your tests are not actually what you want your program to do, you're going to have a bad time. And then I have a second test case which deals with just one vowel. So hen I expect it to equal HN, he I expect it to equal H, and I deal with words that are made up entirely of vowels. So a lowercase a should become nothing, and all a's should also become nothing. And I've also got this function called hasA. What hasA does, it just checks if the word has an a in it. And if the word has an a in it, here are cases where I expect that to work, because there are a's there. And here are cases where I expect it to work in that there is no a in the word. And so I'm going to run my tests again, because actually I should be failing more tests. And so in this test suite, it tells me that one test suite has failures in it, that test suite being the checking multiple functions, remove vowels. And it tells me that when I say that I expected capital ABC to equal ABC, but instead I get equals BC. Sorry, I expect it to be BC, but I get capital ABC instead. So it doesn't match my expectations. And the next one, I expected to remove all of the A's, but it only removed one A. So it's similar to writing tests from before, but it gives us exact details about what we expected to happen and what's actually happening, which can point us into how we can fix it in the future. So does anyone have ideas of how I can fix my functions? I've got remove vowels, and I'm just replacing lower cases right now. Where did I fail on? I failed on upper cases, right? So I should probably add another 10 if statements just for the uppercase side of things. But the simpler thing that I failed on is that I failed on multiple. Yep, was that a?
I wanted to ask, is there like, you know, for C we can have ASCII tables and kind of like write 64 or whatever, 24.
Yep.
Do you do something like that for JavaScript?
I know that you can in Python. I believe it will be called the ordinal value in JavaScript. Will give you the number representation of a character. But I haven't played around with it myself in recent years. But ordinal values are some of my favorite things because you can go 64 plus something and then turn it into an uppercase A. So you can play around with that, but it's not as, well, in Python it's not as straightforward. In JavaScript it very well might be. I wonder, let's find out. I'm just going to quickly check. Console.log A plus 32. Nah, it doesn't quite do it like that. You'd have to convert it to the ordinal value and then add it and then convert it back. But good question. Normally we'd deal with this with the regex, but the first thing I'm going to do is actually instead of, so what I expected .replace to do, with the name like .replace, what do you expect .replace to do? Replace, yeah? Yeah, I expected to replace every instance. That's what I thought would happen. No, what .replace does is replaces just the first instance and says, the other ones are fine, which is not what I wanted to happen. So let's change it to .replace all, which should now replace all instances. Now, I'm actually going to leave I and O unchanged because I want to demonstrate that your testing is only as good as your testing, which is a bit redundant, but I'm now passing that test case. However, my code shouldn't actually pass the test cases because what does my code fail on now? I changed A to have replace all and E to have replace all, but what will it fail on this time? I, O, U, sometimes Y. So it's very important that you're doing your testing as thoroughly as you can.
So could you use like .map and then replace?
That is a very interesting question. Could you use .map and then .replace? I've not played around with it. I'm not sure, sorry. The strings library is vast and varied, and you should play around with it and find these things out because it's very cool. So yes, you can use this command to make your tests actually run. We talked about which of these tests would fail, and you must think about your code at all times during development. I think about my code basically 24/7, but I do expect everyone else to have slightly more of a life outside of university, so you can think about your code between the hours of 9 to 5 on weekdays. I went over the general structure, but the outermost describe is a broad area of what we're talking about. And then we have inner describes that describe each test scenario that we're testing. You can have as many describe layers as you want. And the tests, we then test for each individual behavior. So we don't just say, testing my function, and then put all of our tests under one test label. We say, testing for blank, and then the test that tests that side. Testing for other blank, and then test for that side. You should read the Jest documentation, because I might ask you, what about, we can do maybe to be null, or to be truthy, or to be greater than, or to be less than. So I could say, I expect remove vowels ABC to be less than 12 if I wanted to. So all of that weird syntax I talked about, don't worry about it too much. The brackets followed by an arrow, followed by curly braces, is an anonymous function in JavaScript. It's a function that doesn't have a name, but I don't expect you to know that. But I do expect you to be bewildered by the fact that you can pass a function into a function, and you could actually pass functions into functions into functions if you wanted. But if you just memorize what the syntax is, I'm going to be happy enough. I'm not expecting you to worry about what is this anonymous function shenanigans. When we are designing things, we are trying to do design by contract, which is where we give you the specification and we expect you to conform to what we're specified. So in here it says, it returns a new string with the vowels removed, and the input is a non-empty string, and the output is a non-empty string. But so who thinks that this is a relatively robust description? Who thinks they could go and program it based off that? Anyone? Yeah, you could probably give it a shot, right? You could try. But who thinks there's more questions they might want to ask? Yeah? Who's tired? Yeah, it's okay. We're almost at the end of the lecture. I won't take up too much more of the time. But sometimes, so we talk about how the program acts in terms of its behavior, but it's difficult to understand every possible instance of behavior because people don't behave normally. The reason beta tests are so popular and early access on platforms like Steam is so popular is because having 1 million people test your product is way better than one person doing it. But oftentimes there is undefined behavior. So I'd say to you, deal with strings and give me a string back. And you might say, what happens in this scenario? And I say, I don't know. So oftentimes when we deal with undefined behavior, when the user hasn't specified well enough what the behavior should be, it's up to you to figure it out and to decide what it should do. And it's the same with implementation defined behavior. Sometimes that undefined behavior is implemented and becomes defined, but only by the implementation. And sometimes in your teams, implementation defined behavior will differ from team to team. Hopefully in your teams, you'll come together and decide how to deal with undefined behavior. But from team to team, we do expect it to vary slightly. Right, that is a good chunk of dynamic verification and testing. I'll stick around for another 5 minutes. If anyone has any questions, I'll look at online for any questions. Someone has said, oh, someone's asked a good question about style, about whether we should use has_a or has and then a capital A, which is camel case versus snake case. The answer is, I believe there's a 1531 style guide that will tell you what to do. It should, I'll check, there should be a style guide on the website, and if there isn't, then do what you please if there's not a style guide. I'll double check and I'll put it in the next forum post. But the main thing is, we will cover all about style and whatnot in the next lecture, which is about static verification and linting. Thank you all very much for coming. I'll be here for the next few minutes. Thank you.